Good morning, everyone. Oh, I'm reaching for my coffee mug, but it's not here. Hopefully my audio is working. Should be. Morning. Good morning. Here's my workbench in the state that it was last. AKA a disaster. Actually, it's not too bad today. Couple of things to note. I'm going to move this though. I really need a permanent spot for my camera gear. I need a permanent spot for a lot of stuff. There we go. This came in the mail not too long ago. Let's see if I can show you what this is. Don't think you're going to get quite enough resolution there. So it's a RP2 B2. So I think this is an RP2, like a Raspberry Pi 2W. Hey MT, good morning, how are you? And then this one. So I'm not sure if this one is legit, but this one here says RP 2350. So this is an RP2W, and I don't think they're made by Raspberry Pi yet. Raspberry Pi hasn't released their RP2Ws yet, but this is essentially an RP1W, both of them, which has been converted to be made into a W. So that should be pretty interesting. Oh, you have a man cold. Damn. So I'll tell you, I caught a cold or something on Christmas, 24th, 25th, somewhere around there. And I'm still coughing now. So it's been over a month. So I feel good, I feel okay, but my throat's all messed up and I'm coughing. So yeah. Have you guys checked out the video of the HT118A versus the HT118E? That was a decent video. Not many people watched it though. This was my quest to find a dollar store light that would work for lithophanes. Spoiler alert, they do not. So I gotta tear this down at some point, and these as well. This little eye zoom. These are actually terrible. I wouldn't buy these because they run on coin cells. Pretty crap. But I was looking for something, an all-in-one solution that wouldn't burn down someone's house. I got some diodes. Oh yeah, I've got a project, a PCBWay project, but I need to figure a couple things out first. But look what I got. Look at these bad boys. Caught the video. Your A still great. No upgrade. Yeah. For sure, you don't need an upgrade if you already have the A. Look at this bad boy. 1000 volt, 225, 2.2 nano microfarad. So there's, I think it's called an MVA adapter. So there's an adapter you put on your multimeter, and you use this and a diode and a discharge resistor, and essentially it's for testing old ignition systems. So I think it's a cool concept. I'm going to make, these were expensive. These were probably like, I don't know, there's 5 of these. This is probably like 20 bucks. But I'm going to make an MVA adapter, because if you want to buy an MVA adapter, it's like 100 bucks. So yeah, I just need to find a good way to demonstrate it. I want to see if my function gens, if they can demonstrate it. But it's essentially you turn an AC wave, because essentially the ignition system is like an AC wave, but it's not constant. And the capacitor sort of flattens it out and turns it DC with these diodes. So these are 1000 volt 1N4007 diodes. And yeah, with these two, you flatten out the wave and it gives you an average DC. And that average DC will be given in a service manual, like a service book. So it tells you if the ignition system works properly. I have to do a little bit more research than that before I go ahead and make the video, but that will be the goal. My freaking stuff is underneath my mat. Get out of there. There we go. So yeah, super easy tool to build. You don't even need 1000 volt components, but I wanted to just in case. And PCBWay video going to be done with that. I mean, it's a PCB. It'll be probably about that big. I'm going to make a case for it, and then people plug in their multimeter leads, and good to go. So yeah, that's the plan for that. So this was really expensive, though. I'd love to see if we can use a inductor and a transistor switching on and off to try to try to charge this up to near 1000 volts and play with 1000 volts. That'd be pretty cool. Then I've got these. So these I wanted to unbox on camera, but I'll just do it for you guys. But these things are pretty cool. So these are, I don't know if you guys recognize this. You recognize this? This is an Arduino Uno R4. However, this is a clone. This one is straight up a ripoff. Like, you know how Arduino allows clone? It's open source, right? This one has all the fake labeling on it, everything. That is crazy. So I'm tempted to buy a real R4 and compare it to this. Look at that. They went through the trouble of using silk-screened I/O. Oops. Look at that. This looks like a legit. Oh, it's silkscreen on both sides. You see on the inside as well. Look at that. So it's got the matrix display. The goal is I want to plug this in. I want to see if it works with the actual Arduino software. Look at that. So I got 3 of these. They were not cheap for a clone. These were 16 or 17 bucks each. I got 3 of them. But I'm curious to see if it'll work like the original. So I guess I have to order an original. Let me put that on my list. I think it's good to support Arduino anyways. So even if I pay whatever amount of money, let's close this. Arduino.cc. Just want to see. Buy an Arduino. I don't want it. Hang on, I'm going to send you to the naughty chair. Go away, go away. Okay. Search Canada. I don't want it to assume my location. Okay, I think we're good. Go away, go away. Screen. All right, boards and modules. So this is the Canada store. No, it says USA. Okay. Let me see. see the R4. There's the R4, but the minimalist one here, $30 American. So yeah, I'm gonna have to order one of these. I mean, it looks pretty close. Yeah, so anyway, so I'll order one of these at some point. And then I'll have some legit things to compare. It's gonna be interesting. But yeah, this thing is nuts. Like to go from a basic Uno to something like this, and they kept the same form factor and they added like freaking an LED matrix. Like, this is crazy. I think $30 might be a little expensive, but it depends what I don't even know what the chip is capable of. It's no longer an ARM or an Atmel chip on it. It is whatever this is. Actually, let's go read the specs. I don't know the specs. Let's see. I know it has the ESP32, but I think it doesn't only do Wi-Fi. Let's see. The RA4M1 processor from Renesas with the ESP32S3. Let's see. All right, so 12-bit DAC, that's nice. I think the Arduino was like 8-bit. CAN bus, so that's good. An op amp. 24 volts. HID support, that's nice. Bluetooth, yeah, Wi-Fi. Has the quick connector. Real-time clock. Oh, it has pins for real-time clock. Doesn't have a real-time clock. Okay. So 14 digital I/O, 6 analog input, 1 DAC, 6 PWMs, UART, I2C, SPI, and CAN. 8 milliamps per I/O pin. 48 megahertz on the main core. And then the ESP32 is up to 240. But I don't know, do you use the ESP for other than Wi-Fi stuff? That's it. There's no other information. Huh. Interesting. So we'll have to see what gives. They put the clone put this little heart on there, but I don't think they put solder on it. So yeah, I'll see if I can find a legit supplier and get a legit Arduino. I'm thinking this big fuse, I don't know if that big fuse is there on the one I have. Oh, it is. It's different though. Right there above my thumb. The JK fuse. Well, we'll see. We'll just have to see. These clones look really good though. I just wonder if it's going to work the same or if it's fake. Here's the quick connector, the QIIC or whatever it is. Yeah, very curious to see the difference between that and the OEM one. Also got this guy in. You guys have to hold me accountable. I got to do more microcontroller videos, especially now that I have AI that can program for me. So look at this tiny guy. This is the, shouldn't have cut that, ESP32C3 OLED. So this is a Small little fella. Look at the size of this thing. So ESP32C3 with the tiniest little OLED on it, little display. I think that actually the C3 is back there. So small, tiny little board with a tiny little display. Probably not going to be able to show much on the display, but I think it's pretty cool. This thing was like cheap. This was probably like $3 or something. So I love tiny microcontrollers, like for example the DigiSpark. The only thing is it's so limited. These things, this is a full-fledged ESP32C3. So the C3 is not as powerful as a lot of other ESP32s, but look at it. It's freaking tiny. It's just roughly bigger than the top knuckle of my thumb. Tiny. So that's going to be nice to play with. This is too late. Yeah, there won't be any more text on there. So that's good. Been getting stuff in slowly but surely. Stuff is about to get a little rough around here because of the tariff stuff. But, you know, I should have electronics projects. I should be able to keep doing PCBWay videos, support myself. It should be completely fine. I am off, actually, next week. So hopefully there'll be more live streams because I got to work on more videos. I remind you, if there's a purchase you think I should do for the channel, there's a form in the doobly-doo down there. And also there's a list, I think there's a form as well for video ideas. So if you got circuit ideas or video ideas, hit me up because, yeah, got to be making videos. This is only here because I needed to sort it into my fishing stuff. This is actually a student last semester gave me this as a thank you for being her teacher, essentially. I talked about fishing exactly one time because a student brought a fishing rod into the classroom and just like left it, but not where he was sitting. And I was like, "Oh, you're going fishing?" And then he was telling me where he was going and stuff. I was like, "Yeah, okay, best of luck, man." And then I was saying that I do some fishing from time to time. And yeah, she bought me this at the end of the semester and a gift card to McDonald's because I was show up with my McDonald's coffee. So that was really nice of her. So I'm going to put that in my tackle box, and then this year, hopefully, catch fish on it. I already upgraded my fishing license, or upgraded. I already bought my fishing license for the year. I buy it for 3 years because I'm too lazy to renew it. So I got 3 years of fishing license charged up on my card. I'm good to go. Oh yeah, I need to buy another fishing license though. So we live on the border of 2 provinces, Ontario and Quebec. And so if I want to go fishing in Quebec, I need a Quebec license. And if I want to go fishing in Ontario, I need an Ontario license. Long story short, I go fishing on both sides. So 1 year of the Quebec fishing license is equivalent, is more expensive than 3 years of the Ontario fishing license. So that's great. That's because I'm not a resident of Quebec. I'm a resident of Ontario. It is what it is. So I've got something to unbox. I don't know if I want to record the unboxing or if I just want to do a video. Like if I would just want to do the unboxing with you guys, have a little play, and then make a video separately. I don't think unboxing of this is super important. This was kind of expensive. This comes from the idea for this. Well, I've had this in mind for as long as I've been making YouTube. I found it on AliExpress. I found it a little bit expensive for my tastes. So I was like, one day, I'm not ready to buy this yet for what it is, but one day. And then, geez, what's his name? My God, I'm so bad with names. Since I've been teaching, I did my intense teaching contract for 2 weeks. My brain is like mush now. What is his name? I have one of his boards right here. Unibyte. Jesus, that was difficult. So Unibyte got one of these in the mail, and I was like, screw it, it's time. Pull the trigger, I'm buying one. My hope is that I'll make videos with this, and Unibyte will make videos with this, and then together our videos can be, we can reference each other. So anyways, we'll unbox this for you guys. I don't think I'll do the video for this, for an unboxing of this. I might do a video just showing what it is, but I don't think I need an unboxing. I think the lights are a bit hot. Let me de-hot. Oh, doesn't track well on that surface. Let's see. This, properties, configure video. Let's drop the exposure. Is it auto exposure? It is. I don't know why it's auto and horrible. That's better. You guys can see a little bit more. I mean, it's white, so you're gonna see what you see, but all right. So what do you think this is? It's big. It's I'll tell you. It is roughly 40 centimeters by roughly 27. It's 40 by 27 centimeters. If you're in Myanmar and Liberia in the States, well, I'm sorry. No guesses, huh? Fine then. Keep your secrets. I love stuff from China. Hopefully what happens with this trade war is that we get like a direct link to Chinese imports. That would be awesome. Maybe the Chinese will will import our maple syrup, and we can import their everything. So here we go. You know what it is yet? Oh, it says there. Oh my God, this thing smells like plastic. Yeah. Ooh, so fancy. Look at the case opens and everything. Look at that. Okay, so this is like, oh my God, that just, whew, that smells of volatile organic compounds. How's it going, Adam? Yeah, I have one of these kits now, and I plan on making videos. I think the goal is I can knock out a couple of basics videos real quick. Like, it won't take a lot of, it'll take some planning, but it won't take a lot of filming and editing, which is the plan. So this is one of those Leyden jar things. There's the manuals for it. Here's a reed switch. You won't see that. You won't be able to read that on your screen. There's the reed switch. This looks like a buzzer, passive buzzer. Some LEDs, a white one. Oh, that's not white. That must be red. So the reason I know is you can look through here and you see no yellow, no phosphor. So that must be like a color LED. But since there's a green one here, which is a diffused style, then this one must be red. So red and green LED. This is a resistor, red, black, black. That is 200. So is this 20 ohms? So 20 with 0 zeros. Does that make sense? 20 ohm. Battery holder. Battery holder. Talking, well, more like cell holder, I should say. They're kind of dirty. That's what you get for Chinese stuff. Chinesium. Another cell holder. A compass. Does it work? Let me see. Here. What? Yeah, so this would be the north pole of the magnet. This would be the south pole of the magnet. Good. It works. These are bars, and they're probably to demonstrate magnetic flux through like a basic motor. I think that's how that works. So you put a bar with a coil and a magnet or something on here, and I think you put power and it'll roll this way up, and you inverse the polarity, it'll roll this way. I'm pretty sure that's what it is. So I have actually one of these kits at the college for teaching apprentices, but it's not a kit like this. It's on a giant board, and it probably costs like $5 grand, but it's essentially this. Here's a single pole double throw switch, SPDT. Single pole single throw switch, SPST. Another one. I believe this is a incandescent bulb holder. Two of them. This is a bell. Oh. So how is this supposed to work? You put power. Oh, is this like a solenoid demo? Like, okay, hold on. Does this mean like that this acts like a solenoid? Oh. There. So does that pull like this until they short? I don't know about this. Because this is, okay, hold on. This is just power. This is just one contact. So the other contact is here. And you see, when it would go away, it disconnects and then it lets go. So it just will oscillate. I don't know. Here's a motor. Very primitive motor. Where are the brushes? Oh, there are the brushes. That's excellent. Yeah, look at those brushes there. Excellent. So that's really nice. We can get this powered up. Maybe we're going to get this powered up as soon as I go through all this. Another couple of resistors. So we've got Brown, green, black. That would be like 1. Is green 7 or 5? 1, 7? Oh, 5. Look, it says 15 ohms. 15 ohms, 10 ohms, and 5 ohms. So that's good. And another bulb holder. So there's like 3 bulb holders in here. We put this all back before we go underneath here. So I got the deluxe version of the kit. I wanted to get like everything, you know? I wanted to just literally get as much stuff as possible, because the problem with these kits, they're quite pricey. This one is probably like 80, 85 bucks, something like that. So they're quite pricey because the shipping is a lot, because as you saw, it was a big chonker, lots of stuff in there. Oh, see, that doesn't fit well in there. Wish they made these all standard sizes so they would all fit properly. The cell holders, no, cell holders are bigger. So yeah, clearly this won't all fit. Yeah, what? How disappointing. So these don't fit like that. Maybe they fit like this. Maybe that's how they fit. Yeah, a little bit. Like giving up on the organization already. I feel like I'm fitting it all better than they did, though. So this really doesn't fit this way? It does, just barely. Ugh. There we go. Oh, with the Leyden jar. Well, didn't all fit, I guess. Come on, guys. I'm hoping it doesn't fit because, you know, they gave me extra, not because they didn't plan for this. I guess that can go there. That can go there. Does that work? Yes, it works. Okay. A little bit more organized than it was. All right, now underneath. Ooh. What is this? Oh, this is the accessories. Okay. So there's a couple like of these leaves. We're gonna see what this all is in a minute. You should have taken a pic on your phone. No, it was a disaster when I opened it. It wasn't all organized. This is really cool for teaching students. It's very clear, the North and the South Pole. Now the interesting is, let's see if they're calibrated, if they're like painted the right color, or if they were magnetized the correct way. Oh boy, this is stapled together. I just want to make sure that the south attracts the north. Yeah, we're good. The north attracts the south. Good. So yeah, you got a horseshoe magnet and a bar magnet. Excellent. Solar panel. This is one of the parts that the cheaper kits don't include. Oh, you've got a potentiometer. So I love this. This is the ideal demo for a potentiometer. So it's like a single wire wound around like this, and then the potentiometer touches the surface and adjusts the resistance. This is a great demo of how a potentiometer works. That is cool. Okay, this, I don't want to pull too fast. So this, you got some fuzzy, furry material, and then you've got acrylic rods, which are very low quality. You see the casting marks. So 2 acrylic rods, and then this one, I don't know, just plastic, like ABS. This is to generate static electricity, probably for the Leyden jar here. It's not a rheostat. Wait, it is a rheostat. You're right. Huh. Wait, how? Hang on, hang on. No, it's not a... Okay, first of all, it is a rheostat. Because, yeah, you use one of these connections and out the other. Yeah, you're right. It's a rheostat. I really wish it was a potentiometer, though. I might have to make my own potentiometer. Dang. But you're right, it is a rheostat because there's no wiper connection. The wiper goes just through here and out the other side, or through here and out the other side. You're right, it's a rheostat. Here's a little magnet car, so you can use the bar magnet. Potentiometers can be wound like that, though. High current potentiometers are like that. So yeah, you could. Oh wow, they didn't even paint this this side. Only the top and bottom. That's funny. So yeah, you can demo this. You can demo attracting forces and repelling forces. That's nice. Little traditional electric motor. That's cool. So you can spin it and then generate electricity, or put electricity in and it'll spin. Let's see. Oh, this probably is resistive wire. So this you can demo a potentiometer on as well. But I'm guessing it's like nichrome resistive wire. I have to see what the translation is for those. And that looks like the wire goes through the center tap as well. So anyways, you can measure, resistance per distance. Okay, little crank dynamo. This probably goes with, this motor probably attaches right here. And then you can crank, and then you can generate a lot more electricity because of the gear reduction, or the gear increase, gear ratio change. You got little, pretty sure this is going to be iron filings. Yeah. Not very strong magnet. But if we use a stronger magnet, it should be more bigger. Yeah, there we go. You guys probably have trouble seeing that. So I like these because they are encased. You don't need to worry about it. There we go. You can see it. You don't need to worry about having iron filings everywhere. So this is to visualize magnetic fields. Like so. You've got a coil, probably to demo a solenoid. There's probably a steel rod that goes in here. Here's my accessory pack. So in here you got a little fan, you got some wire. There's a brass rod. Oh, here there's a nail. So that nail you probably use for two things. It probably fits in here, and you can demo an electromagnet. And also, you could probably put it halfway in and then turn on the current, and it'll get drawn in, and that'll show the solenoid effect. Oh, some more magnets. Oh, I'm not sure. Oh, that must be the plunger. It was stuck on there. Does that fit in here? Yep, there we go. So it has threads as well. Oh, nice. So you could probably have a rod sticking out and make it do something. Well, that's neat. Shutter, payday tomorrow, and about to drop 300 pounds plus just on 2 hard drives. Oh, I'm well aware. I have to do that too. I have to build a NAS. I should have built it last year. There's a tax thing where up until last year you can do a full deduction on equipment that you're using, that you buy for purpose of doing business. And like a NAS would be one of those. And because I'm going to be doing it this year, that means that I won't get the full deduction. I'll have to deduct it over the course of 5 years. That's annoying. So these little compasses, very nice. What is this? I'm going to check out the manual, but I don't know. Oh, maybe it has something to do with this? So this is like a little a coil that you could probably affect stuff in that fit in there. No? Well, I'll figure it out. But yeah, this is like a coil of copper wire. I had the NAS for Christmas, just not the drives, yeah. Drives, you gotta wait for a sale though. This won't need the packing anymore. When you, like Western Digital has sales every once in a while where you buy 2 drives and you get free shipping and 20% off on their website. You just got to buy 2 drives at the same time. Okay, now this is interesting because it's 2 thermometers. This one has like distance on it. This one has degrees Celsius, and that's about accurate. It's like 18 in the room right now, so this is accurate. There's something behind here. Okay, the resistors. Oh, okay, so it's you can show the resistors heating up. Oh, okay. Oh, there you go. So you got resistance values here, and you see how much they heat up these thermometers. Oh, that's interesting. They're not calibrated though. Like they're not sitting at the same distance, so you might have to push one down. That's pretty intelligent. I like that. A couple of these wires to hook things up. And then we're in the last 3 components here. This, I believe, is a galvanometer. I'm not 100% sure. I think it reads like magnetic flux. Is that possible? I don't actually know what this measures. I'm not 100% sure, but I'm going to look it up for sure. And that's another thing. The cheap kits don't have that included. Here is a voltmeter. So looks like it's at 0 here, but it goes down to -5 and +15. That's pretty cool, a balancing coil meter. And a current meter. So it looks like it needs a little bit of twiddling of the pot here, but it goes from 0 to 3 and then down to -1. Oh, I didn't notice that it has 2 scales. So this one here goes from -1 to +3 on the low scale, this one, and then the high scale up to 15. This one, the low scale, -0.2 up until 0.6. So this is a really cool kit. There's a lot of stuff in here. So for 80 some bucks, you know, on YouTube doing tutorials, I will definitely not make that money back, but that's not the point. The point is to do it. So that's pretty cool. Chinese kit with a lot of stuff included. I really don't know what all the stuff does yet, because there's a lot of it. So if you're like interested in this, you know, the basic series, you got to let me know, because over the next couple of weeks here, is the best time to make videos. I still don't know what this is. I have to go look up the instructions. No idea. Over the next couple of weeks will be the best time to make videos because, like next week, I have off of work. And the reason I have off of work, 2 reasons. 1, I'm exhausted. I need to rest. But 2, there's not a lot of work in the automotive job. My college contract is done. The automotive job, there's not a lot of work. So there's no work for me, essentially. So it's sort of like a forced time off, but it's not like I needed it too. So it worked out. So in spring though, it'll be very busy, and that's when I start, the fishing season will start in late spring as well. So the best time to make videos is nowish. So if I can knock out, if I can spend a day and knock out 10 of these videos, then edit them over time, that would be the ideal for me. It doesn't feel like this will be very difficult to produce. It's not like a big production. Well, YouTube is work, but not in the same level. Like, I work for myself. I don't have any boss to report to, just you guys. And you guys are mean. Just kidding, you guys aren't mean. Some of you are mean, but not the people that are on this stream. Some of the comments are mean. One day maybe I'll make I reply to mean comments video. That'd be pretty good. So yeah, neat little kit. I actually, I don't know how long some of you have been around, but I've been working, because I was inspired by that kit and kind of like upset at the price. I've been sort of working on my own version. I'm looking around here because it's in these boxes somewhere. Hang on a second. There, no. Where? In here? Yeah, in here. So I was working on something similar where I was trying to do my own little blocks like that, but I wanted them all like the same arrangement. So yeah, these were my attempts, and the goal. See, look, I got all these little meters. What do you expert in those kinds of replies? Been on Facebook since ever. Yeah. What do you? I have 8 videos recorded and uploaded this month. Shouldn't be working on the rest. Should be working on the rest. Yeah. So yeah, I had bought all these things to do exactly like what this is, and I just the problem. Look, I designed. Here, I'll show you one of my problems. See, I designed a holder, and then the holes aren't the same for all of the devices. So this one doesn't fit. So I was like, all right, I gotta make slots for holes, right? That makes sense. So now I can fit ones that fit up higher or up smaller. But then I received my current meter, and it doesn't fit because now it has a giant caboose on it. So that didn't work. And I was trying to get these resistors somehow on there and then have everything equidistant. And I was like, screw it. And like, on hindsight, I could have been working on this. It wasn't that bad, but yeah, I just abandoned. So yeah, that was that. So yeah, these can probably go in the trash now. I'm gonna keep these meters. I like these meters. I'm gonna put them somewhere. But yeah, this project kind of ended up in the trash. FreeCAD is doing your head in. The new one, FreeCAD 1, are you liking it more than the previous versions? Because I wasn't a fan of the previous versions. Let's just put it that way. Oh boy. Big stretch. Oh. Oh yeah, and two more things to show you guys. Never used it before. Ah, gotcha. Bought some tools. The UT 8805E, I think, the multimeter. Hold on, let me turn it on. Yeah. The multimeter has a massively loud fan. So I want to switch it because you can't record with a super loud fan going on. So I decided to get a sound meter. So I got this Unity one. Look at the boxes all broken up. But then I was like, well, they have a light meter. I bought two. So now I have a light meter and a sound meter. I'm gonna make a video on these individually as well. This will be like a 10-minute video to film. So let's see what my noise floor is here. The only thing I don't like about these Unity things, they use batteries and they're AAA. Like, yuck. Why AAA? Put a pair of AA's or something, but it's like 3 and it's AAA's. Who does that? And in this bag, I have 3 AAA's, different brands though. Whatever. If I blow it up, I blow it up. I need to order more rechargeable AAA's because I put them in devices and then I put the device away and then it goes missing. I don't know what device I had put it in. So let's put the fancy cell in the middle here. Oh wait, no, I have the odd cell out goes in the middle. There we go. So and like so. Right on. That is loud. Noise floor of 45 dBs. Let me turn off here. Let me put this on a surface. Like 45. Now let me turn off the multimeter. It's averaging a little bit, but yeah. This is a loud recording space. I record in this friggin' space. Doing the fire alarm sounder test, took a sound meter just in case, ended up needed it. It was like really loud. Is that the deal? So let's see. Let's see how fast it responds. It's pretty good. So it'll probably give you better averages. Pretty nice. It's a nice little toy. Manufactured 2021, 12/18. This has been in the factory for a long time. clients moaning they couldn't hear the alarm. Sounders were proved to be above 90 dB. Jesus. I think they need their hearing aids checked. I had to work yesterday doing the oh, you were doing the test. I thought you were working during the test. Now I understand. Yeah, freaking 90 dB is loud. I know, like, my parents' house, my dad is a bit hard of hearing, and my mom is as well. But my mom keeps complaining that my dad is hard of hearing, but she's also hard of hearing. She doesn't understand. When I used to go there before my dad got hearing aids, they had a TV war. Like, my dad was in one room with the TV blaring, and my mom was in the direct opposite room with the TV blaring. They each were blaring the TV because they were having a hard time hearing their own TV. And, like, they're old, right? So they don't think of the same solutions as young people. They're not like, hey, maybe we should just get headphones or get our hearing checked or anything like that. No, it was more like, just turn up the TV. What's HOH, parents? What does HOH mean? I'm not familiar. There we go. So, my studio lights, 5,400 lux here. Let me turn this down. 3,400 lux. Can't reach the swivel knobs on this too well. There we go. Now just the overheads, 1,800 lux. I actually, Dave Jones of the EEV blog took some measurements of the luminosity in his on his workbench, so I should compare that to how much I'm using for my filming. I know I like to film very bright because it allows me to shut the aperture. Oh, hard of hearing, gotcha. It allows me to shut the aperture on the camera because I have a DSLR, big sensor, so I don't get much depth of field in focus. So using very bright lights, it allows me to shut that aperture down. My power supplies are whining. I'm gonna unplug it. I don't think I need it right now. Ugh. Ugh. There we go. No, I'm having, there's some more high-pitched whine from somewhere. Might be the transformers for my lights. Anyways, yeah, it allows me to stop down a little bit. I actually want more brightness. I have these two lights on the side. They're like probably this big each. So one is hanging over this shoulder, the other one's hanging over this shoulder. This one's a little bit further away, so you do get a little bit more light coming down this way. But they make some versions of those lights which are double the size. I want them, but I think they're discontinued because they're almost always out of stock. And they're expensive. So these lights, I think they were like 120 bucks for the pair. But I want the bigger ones. I want more light. These are cranked all the way. I would like them not to be cranked all the time, because these are like as bright as they go, essentially. And you could see here, you could see the shadow here. So that's this light here. And then you see this shadow here, this area here. That's that light. In fact, I think you guys see it in the reflection. So that's the ones up top that you see there. That's the ones straight up top. If I turn it this way, should be able to catch it. I have to be able to, oh, no, that's up top. Where is it? Oh, there. So there's the light that's there. So you can't really see the definition. There you see the little crack. That's where the shield is, the barn doors. And then this one here. See a little crack there? That's where the barn door is. So you've got light directly that way, light directly that way, and then these lights across the top. I also want to add some lights across the top here. But I'm running out of room, and these guys, the ones up top, they stay cool, and I'm afraid that if I add more, like more light density, they're going to get warm. Lux meter is made in 1960 and never needs batteries, so it's like solar panels essentially. It shows you an output based on the amount of light that falls on the solar cell. Does that make sense? So yeah, these videos will be quick to make. It's pretty cool. Nice little tools. I keep adding to my arsenal, and I was like, well, if I want something reliable, like these were 30 bucks a pop. That's magic in a steel box. These were 30 bucks a pop, but I could have got some random, like unbranded Chinesium ones for 20 bucks a pop. But I was like, why not pay the extra? Because I know Unity makes good equipment. Like this is, like people call me a shill for getting the Unity meters. But it's like, no, you don't understand. When I wanted a cheap but effective tool, I bought Unity. I've always done that. I have Unity stuff all over the place here. I even bought like this when I wanted a 2-channel thermocouple. I bought this. This was not sent to me. Neither were these two. I buy the most effective, cost to performance ratio. If you buy a cheap Chinese thing and it works, you can't trust the result, A, and B, it works only half the time. What's the point? That's my theory. So, yeah, these two, I think these two are pretty cool. Branded Chinesium instead of, yeah. So that's the difference, right? Even if they were exactly the same, the fact that this one has Unity on it means that there's some sort of QC that has to be done by Unity. And if they don't do it, you can go after Unity. You can complain to them. If your unbranded Chinesium thing doesn't have a brand, then who are you going to complain to when it doesn't work? Like at least Unity has to uphold like a minimum amount of stuff. They have a minimum reputation to maintain. Whereas, like, if it's just some random Chinesium bottom of the barrel stuff, there is no reputation. There's no, who cares? So yeah, that's that. Did I get anything else in the mail? I don't think so. Lots of fishing stuff because I'm pretty excited for fishing season to come back, even though we're in February only. Got my fishing rod in, which was nice. Can't show you that on camera, it's way too big. What do I have left? I just need to sanitize my hands after touching all the Chinesium stuff. I always use when I'm upstairs and I'm dealing with the mail, I just wash my hands, but I don't have a sink down here. So I use hand sanitizer when I fiddle with too much Chinesium stuff, You never know. Anything by the mail, right? Because you don't know where people's hands have been. All right, so now what do we do? There's a lot of stuff we can do. All right, let me get my notebook. I had a call with a potential podcast guest, which was really nice. They seem interested, which is good. So here's something I would like to do, and we can start this today. So I have these servos. Probably have one that's already. All right, so here's what I want to do. So here's these servos, and they claim to be 150 kilograms force. So it's kilograms force, I think that's, anyways, whatever. So servos. You guys probably can't see that. What do I do here? What should I do with this? I have an envelope here that's not opened. Should I be worried? This is literally unopened. Where did this come from? It was probably in something, and it fell to the side, and then I didn't see it. It's a thank you card. Oh my God. I didn't even... Hi Dan, thanks for having me on your podcast, Steph Piper. I put all of her stuff on display over here. I didn't realize there was a little card. Damn it, Steph. Sorry. No, thank you for being on the podcast. All right. Focus. Focus, 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 focus. Hocus pocus. Dan needs focus. If I bring you up. Okay, you can kind of see that. So servos. All right, I wanted to test them. Test. Servos. Okay, so they all have a force that's claimed on them, 150 kilograms of force. Okay, if you want to test them, you test them for force, voltage, and current. So you do like a test suite, right? But before you do that, you need a servo tester or a servo, yeah, it's called a servo tester. Okay? Servo tester. What the servo tester does is it sends a signal from, I think it's 0.5 milliseconds to 2 milliseconds, something like that. And also it does centering, and it does, so because a servo, this is a rotating arm. I don't know if I'll be able to back drive that. That's a lot of force needed. But you have a servo arm, and essentially you need the servo in the 0 position so that you can position, or the center position, so you can position your arm on it. Because you see these teeth? That's all the granularity you got. So centering, and usually it does a sweep as well to test to see if everything is smooth. Okay, so these servo testers, you can buy them. They're like probably like $3, $4. But you can also make them out of Arduino. So first things first, we can make this project a servo tester. So that would have to be number 1, servo tester, electrical. So I can design this, prototype it with you guys, and then we'll make a PCB out of it. And then, after that, you can design a servo force tester. And we can calibrate that with an arm. So essentially this is 150 kilograms, but at a certain length. Yeah, you can make one from a 555, but they're not as good. I'll say it right now, they're not as good. So servo force tester, you would use a load cell like this. Oh my God, I'm gonna break it. Well, I already broke most of it, it seems. I'm gonna break the rest of it. Come on, get out of there. All right, so you use a load cell like this and a calibrated distance, and it would push here at a point, and then it would give you your servo's force. So you use a load cell, load cell, and then at a calibrated distance, and then you would make it go, and then it would show it probably on a display. So this is, again, an ideal Arduino project, number 2. So you make this would be incredibly useful, and then you publish the everything, and then we can go back up and go around all of my stuff and test all my servos. So that's video 1, 2, and 3. These 2 can be sponsored by PCBWay, which is going to be needed. And there, so we've got a 3 thing. So as long as we keep focusing on this stuff, we should be able to get it done. So as long as I make a plan, because a lot of these things I can work on while I'm listening to a podcast, which is like time that's essentially wasted, right? It's my recreation time. But I can work on these 2 things, get PCBs made, send them off to be manufactured, and then, so 1, 2, and 3. So this is one thing I'd like to do for sure. So this will be simple. We can mock this up right now. So probably going to do that, mock this up, and then if we have time, we're going to start on the PCB design. So I think this is a good place to go. Also, I need to plan on my Unity videos and some more videos, like easy ones, like knock out the 2 sensors. I just don't have any ideas on how to make them work right now, so we're not going to do it this stream, but this week there should be more streams because I'm going to be here. But right now, I'm going to take a washroom and coffee break. So I used to have a little thing that I put up here saying that I was going to the bathroom. No? Well, you guys will just have to tell people. Here, I'll just put it on this piece of paper. BRB, coffee. All right, and I'm going to mute my mic so you guys don't have to hear the horrors. I am back. So I love you guys and all, but having peak viewership while I'm in the bathroom is, I don't know. It's a thing. Okay, so this, I think this is still accurate, 1, 2, 3, but I was just thinking of something. I can also have number 4 would be multi-servo controller. So this would be like where you'd have sort of like 8 servos being controlled by some sort of microcontroller, and you can use this to manually control robot arms. We can even use slide pots instead of regular potentiometers. So I like this a lot. So 1, 2, 3, 4. And we'll try to mix in some other videos in the mix, because this is going to be too, it's going to be too much of one subject. Now, do you guys have opinions? What kind of micro should I use for this? Because I've got micros galore, but the micro has to be cheap, available, and kind of standard. So, like, Uno is not super cheap. It's also a little bit overkill. It's what I like about Unos is they're good for beginners, because Unos are like the standard, the de facto standard. But I don't think this is the right micro to do this. I'm leaning towards a Pi Pico. This would be great, a tiny Pico, but again, it's not like ubiquitous. This is M5 stack, got a couple of them. What is this? That's a pulse monitor. These are motor drivers. Like, I know you could definitely make a 555 version of a servo tester, but they're difficult. They're a bit beyond my mental capacity at the moment. So I got a lot of these ESP32 Dev Kit Cs. Again, I don't know if this is the correct. Here's Pi Pico. Man, the Pi Pico is everywhere. Wait, another maker made me buy a whole bunch of dev kits. What were they? They're little. So is this a Pico 1 or Pico 2? I believe that's these are the Pico 1. So I think this is a valid option. But I've got really small Picos somewhere. Yeah, look how many ESP32s I have. Pro Mini. Okay, hang on here. Because another maker showed me like these mini ultimate Picos or something. I mean, they must have ended up. Okay, this is an option for real. These are ESP C212s. These are like low power, inexpensive. How's it going, Gerald? So this is an option. So far we've got the Pi Pico. This is Pi Pico, right? Yeah, Pi Pico. We've got the ESP C212. I'm looking for a cheap, small, ubiquitous microcontroller to design a project around. Wait, ESP is 3.3 volts. Is that going to be a problem? I'm going to have to level shift that. These guys. I think it's these. You know what? This might be the ideal candidate. No, not these guys. Something similar. But these guys are an example. Okay, there's one open. So I've been wanting to use these. So these are they're the Pi Pico chip. Here, let me show you. Let me show you. So this tiny thing. So there's the Pi Pico. You see that little guy? Pi Pico. Plus, it's got memory on this side. So RP2040-0. Look at the size of this thing. I have to check the outputs, see if I can do enough PWM. But this would be ideal. These are so cheap. I think they're like $1. Let's go check, because I think this allows me to use the Pi Pico infrastructure, like because it is a Pi Pico. USB-C. The only thing is there's no mounting for this. I'll have to figure out some way to clip it, or I guess it'll have pins, and I'll put that down on a daughter board. Now that makes sense. Okay, let's check the outputs here. RP2040 Pico. First of all, let's check the price. So if we go to screen, actually I'll send you there until I go to AliExpress. AliExpress.com. All right, so I am not signed in here. Let me just see what it defaults to. Ship to Canada. Good. That's good enough. Right, screen. All right, so RP 2040 Pico, was it? I'm getting old. 0. All right, let's check the price. Yeah, that's a welcome deal though. So that's not a welcome deal, like $2 Canadian a piece. So I think that's very reasonable. That's a welcome deal. Welcome, you can't trust welcome deals. So if you get 10 for $22.68, that kind of makes sense to me. Hold on, let me see if I put this on my main account. I need to make an account for this browser. So it's $3 for one, 14 bucks. So they're $3 Canadian each, which is not horrible, but that's not perfect though. Let's see. So 5 is 20. That's $4 a piece. I mean, it's not that expensive, right? If I make this out of a three Canadian dollar, so that would be like $1.20 American. No, about $2 American. Is that too much? I'll just search on my main thing. RP 2040 Pico. 0. What am I saying? 0. 369, 309, 269. Is there shipping? There is shipping. How about this one? shipping. Is that too expensive? Without header. That's really expensive, $5. I think we're good. In the absence of opinions. So this would be good, but I do have another one, which I thought was on my desk here in front of me, but the problem is it may have fallen. There's another one that has more storage built in. There's like fishing lures and stuff in here I need to clean up. Is it this? Yes. RP2040 Ultimate, but that's big though. Hang on a sec. Let's see. RP2040 Ultimate. Yeah, this one. I mean, if that's the same price. If this is the same price, then this would make even more sense. Oops. It's like the same price. RP2040 Ultimate. They are literally the same price. $10 of them for $27.99. Oh, plus shipping. Damn you. Shipping. Okay, so they're the same price. So I can decide to go either way. But I like the Zero. It's so small. Okay, so let's check. We need to figure out the specs here. So RP2040 Zero pinout. Wave share. Is that them? Did they make this? Okay, so 133 megahertz, USB-C connector, castellated module, USB 1.1 with device and host support, low power sleep, drag and drop programming. Yeah, that's MicroPython. Okay, 29 GPIOs, but 20 easily available. SPI, I2C, UART, 12-bit ADC, 16 programmable PWM. So that's what I need. Which ones are capable of PWM? It doesn't say which ones to use and which ones not to. GPIO, PIO, and PWM. So all of these are available, but I don't know if the ADCs are important. Yeah. They say don't use crappy stuff. That makes sense. All right. MicroPython. I don't think I'm going to do this project in MicroPython. Just do it in Arduino IDE. Raspberry Pi Pico, yeah. Okay. Arduino Pico releases. I mean, let's see if we can make it do something. So there is an RGB LED on that. No, live. Yeah. I know, buddy. Don't think you can use all the PWM at the same time on a 2040. Okay, let's check that. How many PWM can you use at once on a RP 2040? Each slice can drive 2 PWM, so you can use 16 simultaneously. More than enough. I want 8 maximum. So that's the plan. 8 maximum. But essentially I need 1 to 4 if you want to be very specific. So I will check, see if we can get that done. Let me send you to the naughty table. I'll just open my Arduino IDE. Make sure that this can work. I'll need to find a USB A to C cable. Yeah, we definitely don't want that. New. There we go. Good. You guys almost saw my Wi-Fi password. All right, back to screen. So there's my Arduino IDE. How to add RP2040 support to Arduino IDE. I know you have to do like a repo or something. There we go. This guy. The JSON. File. Preferences. So I have ESP32. I have M5 stack. This should just be, this should just be a bigger thing. This has got to be a better way. I think you just comma separate and then Control V. Okay. Updates some of your boards. Downloading. So the M5 stack is having issues. Let's see, 2040. Okay, I think we're good. All right, so what? Oh, this is screwing up. Okay. Tools. Board. Oh, I don't, maybe I have to restart it. Okay, let me restart it. Send you the naughty Arduino. That's not good. I do all my programming on Arduino libraries. Back to screen. Tools. Board. So M5 stack is there. No Pico. It's having issues with the ESP32. Did I screw something up? I'll go Pi Pico. Oh, there we go. Is this not installed? It's not. Oh, that's why. Install. Okay, we're installing. Wow, look at that go. also closed for Chinese New Year? What is closed? Like, they don't shut servers down, right? Or am I wrong? I could be wrong. Look at all these boards that people made out of the Pi Pico. That's incredible. Oh, they have the Waveshare products here too. I see Waveshare RP2040. So we should be able to program this Pi Pico. Put a demo sketch into her. My God, this takes a while. I know I should change to some sort of like better IDE, but oh my God, oh, completed, yeah, good, close. All right, tools. Oh my God, this is sketchy. Maybe I should remove the M5 stack stuff for now. Tools, board, Pi Pico, and then go down to Waveshare. Look at all these freaking boards. This is awesome. Waveshare, RP2040. Tools. No FS, I don't know what that means. Trying to get your 3D printer running. Nice. What kind of 3D printer you got again? Do you have, I should say? All right, so let's see, do we have any examples? Examples. Async UDP, hash, I don't know what any of this does, joystick, keyboard. Wi-Fi client, I don't know what that does. RP2040. PS RAM. There we go, there's a servo sweep. Let's see what it looks like. (2015), huh? So servo.h, I know that. My servo attach, position, so it'll do that. Good, that's fine for later. But right now I want to see if we can get like the lights going or something. They don't have like a, because they have an RGB light on it, you'd think you'd let me do something with that. They all do like Wi-Fi stuff. I just want to make sure my thing works. Joystick, little FS. Can I just turn on the light? PDM. Multi-core, get cycle count, fade. There's a fade. Fade the onboard Pi Pico LED. LED built in, but I don't know, because it's the RGB that's built in. Well, screw it. Let's check what it does on the bench. And let's then see if we can modify its behavior. So I have a USB cable here. Ouch, got a freaking shock. This is micro. Don't want that. Don't want mic row, that's for sure. I should have a USB bin. My workshop has been ravaged by making stuff for Christmas, so I don't know where anything is. Looking. There should be a bin with USB cables. Oh, here it is. Idiot. Kidding. All right, let's. Should I put? God damn it! All right, let me put the micros away. So this I'll leave out because that's the Pi Picos. Put all these away though. Take this off my bench. Off my bench. I'm gonna have to switch this box for a bigger box because there's way more micros. I'm gonna have to switch. I'm gonna have to make a second box. One box for my micros and one for my sensors. What's this? That's the servo. That's good. That's okay. This can go in there. All right, this stays here. That's fine. Micro. Charge only. Okay, that's garbage. I can't be out of USB-C cables. That is I mean, that looks like an A to C to me. A to C. Good. All right. Hopefully this can be my programming cable too. Here. Let's plug it in. See if it blows up. It's not doing anything. Okay, hang on. I have to plug this in a known good, or else I don't actually know. USB-C cables near your desk, just use adapters. Yeah, that's not a bad idea. That's a pretty good idea. I really don't want to invest in a Bamboo. No, I wouldn't. Right now is the worst time to invest in a Bamboo. I mean, they still work, but they're locking you down to their own stuff. So what printer do you have? Some sort of Ender 3? Okay, can confirm. When I plug it into a known good, it does nothing. What's the current draw on that? Literally nothing. So I don't know if this is, I have no idea if this is a dead device. I don't know how to program it. So anyways, let's go see. I'll bring my USB-C cable with me. We're gonna see if we can upload a program to it. If we can't, then she's dead, Jim. All right, so first, let me switch to my screen. All right, so first let's check tools, port, COM1 is open, that's it. Let's plug this in. Oh, it opened like a USB drive. UF2 bootloader V3, Raspberry Pi RP2. Why RP2? Do Bamboo? I'm not sure. I'm not sure if Bamboos print right from SD cards. Hang on. I'm trying to read that small text here. It says RP2. I don't know what that means. RPI, RP2. Okay. Do we have a new port? Port. Still just one. If I hit boot when I plug it in, does that make a difference? Boot. In. Oh, okay, I did the same thing. Oh no. Okay, back to WaveShare. Okay, I had the following link. Okay, it'll be in English. You can switch language. Yep, yep. Language field. Yep. RDE, Arduino. Yep. Yep. Done. Pico. Done. No, wait, no, not MicroPython. Press and hold the boot set button, connect to USB port, and then release the button after the computer recognizes a removable hard disk. So we need to hit the boot. Download the program, open D1 LED, existing COM. Okay, all right. So let's see. Got the boot. Plug the boot, plug her in, let go. Okay, so now she should have a port. Port, still only COM1. Interesting. Oh, I hit the reset. Modern controllers must have the boot button. What if I press and hold the boot? Does it show a port now? I just, here, unplug, replug with the boot. Tools, no port. Okay, RP2040 not showing up on my ports on Arduino IDE. Maybe I should have just went for a Uno. Oh, double tap the reset to put the board in bootloader mode. Double tap reset. Oh, that did something. Tools. Port. Nope. Tools. Port. Nope. Nope. Port. Manually copy the UF2 file to the drive. I don't have a UF2 file. Why is this .uf2? Between the rec and ground pins. I have no rec pins. I don't know what an blink.eno.elf.uf2. What the hell is going on here? What have you done? Okay, so okay, so there's the blink.ino.elf.uf2, copy it here, and then we're setting up Nano RP2040 Connect. What does that mean? Device is ready. It's gone. Okay, tools, port, COM1. Why? Why do you do this to me? Tools, port, COM1. UF2 bootloader. All right, time for the big guns. I have RP2040 0 from WaveShare. I am trying to program it. Here, let's put it bigger so you guys can see. I'm trying to program it using the Arduino IDE, so I can program it in C language, which I understand. I installed the boards with the board manager. The board shows up in my board select, but the board doesn't show up in the IDE, as in I can't select its port because it just opens as a flash drive. I tried double tapping the reset button and pressing and holding the boot button. Oh, maybe I have to double tap the boot. Hang on. Let's go. Let's check that. Check that first. Nope. I'll try one more time. Press and hold boot when I plug it in. No, doesn't do anything. Tools, port, yeah. How am I supposed to upload anything to this board? Giver. Well, right now, Google sucks horribly, so AI is the best choice for me. Done. Done. Press and hold the boot cell. I've done this. Yeah. Yep. Right here. Yep. Click the upload button in the IDE. It'll compile and generate a UF2 file. Sorry if I bumped my mic. No, I'm not going to update the latest version. I hate the new version. Okay, all right, let's see. Upload, see what happens. So it doesn't connect it via port. Saludos el colombiano. Okay, so LED built-in doesn't exist. Thanks. So does WaveShare have a... PWM, Arduino PWM D1 LED. Examples. PWM. Should be down in P. PDM. PWM, audio, they don't have it. So I don't know. How about GP16? Equals, do I just type GP16? Maybe it's just equals 16. Ah, then you wonder why I don't try new things. Compiling sketch. Compiling sketch. COM3. Hey, it did something. Wow. It works. Here, I'm going to leave it plugged into my computer because I do have a very long USB cable. See that? It's lit. It makes light. It's lit. A little confused that the directions on the WaveShare are talking about the ESP32 for, no, they're saying since they're saying because you already have ESP32, so here you can just copy this one thing which has the lines for both the RP and the ESP32 if you look down. They're saying like in your URL you should already have the ESP32, which is a bit silly. Okay, you know what else is silly? I can't use pins 9, 10, 11, 12, and 13 for prototyping unless I make an adapter board. So let's make an adapter board. God damn it. This is becoming complex here. Okay. So now, in order to make something, I'm going to have to make an adapter board because this has non-standard pin spacing because of these. So I'm going to make myself an adapter board. I'm also going to make myself a PCBWay adapter board for sure. I'm going to, you know, order 3 things from PCBWay. So yeah, now how am I, okay, let me figure this out. First, let me see. Soldering iron is the correct tip. So I'll put this, actually I'll put it up higher so you guys can see. There we go. Let me grab one of my soldering PCBs. All right, well, at least I know a couple PCBWay projects. Excuse me. I still have a friggin' cough, which bothers me. Okay, so yeah, not using expensive boards, gonna use these cheapies that I've had in stock since forever and a day. So this will, oh, the other way, actually doesn't matter, but it's okay, we'll do it like this. Like so. All right, take this bad boy, drop this into here, this into here, this into here. There we go. Oh, I did something wrong there. Into there. And then this into here. There we go. Okay, so I'm going to solder that up. See how like every little thing when you're making a project, could you solder the pins on the back of the board facing upwards for prototyping? Well, you can face them in either way, but I think it's best to have access to the buttons here. Because if you put the pins going this way, then you'll have issue hitting the buttons. But yes, I mean, you can face the pins however way you want. The other difficult thing about this specific micro is that some of the pins are only available on these little pads. You see these pads just above my thumb? Can't get you in the light. There. See these pads just above my thumb? These are some of the GPIO. So if you want to use them, you have to solder little thin wires onto them. But that's okay. I don't plan on using these specifically. But if I did, like my PCBWay adapter board probably will incorporate these pins, and then you'll just have to solder them onto little solder points. There we go. Or maybe I can make pogo pins, I don't know. So here we go. Let me get some delicious lead solder for my delicious coffee. So when it splatters, it'll splatter into it. I'm also getting old, so I should probably wear my magnifying goggles. You guys probably want to see it closer, huh? Let me get another filament box. I usually use filament boxes to lift my work up closer to the camera, and that works double because, oh, nope, not that filament box, because also you guys get to see it a little bit closer. Did I trash all my filament boxes? Well, I can use literal filament spool. There we go. Hopefully that focuses up here for you guys. Yes and no. Yes and no. Would like to get a manual focus camera for streaming, but that is way too expensive to have that conversation right now. Like a decent, like Sony camera is going to be like $2,000. FreeCAD dimensions work great. That's good. Glad to hear it. No focus, huh? Out of focus? Hang on. Let me, since I'm going to be doing this for a few minutes here. Oh, stop. I need more space. I'm about to throw everything in the trash and start all over. Back to webcam. Properties, configure video. The video panel, of course, opened on the monitor the furthest from me. Camera control, focus. Remove autofocus. God, I wish I could do this dynamically. Is that better? You guys can see a little bit better. Not a lot better. I only paid like friggin' $200 for this stupid webcam. Oh my God, one day. One day, I tell you, I'll have some quality equipment in this joint. Hocus pocus, nothing's in focus. Not as bad, yeah. I'm going to I have to figure something out, because it'd be good to get better footage on the main camera too, on the main video as well. So I am, like, I have solutions in mind, but the problem is it requires a full cleanup of my work area here first, and it also isn't going to be cheap. But I am serious about live streaming, because live streaming is how I, like, this, all this stuff that I'm doing now is required to make the video, to make the project. So now I'm doing it with you guys. It's more motivating. And I'm like, I don't want to say it like this, but you could say it like this, where I'm now, right now, I'm stuck with you guys. So instead of procrastinating, I'm doing my work, you know? And I get to chill with you guys, so it's not as, like, lonely. YouTube is a very, like, one-way experience. I make it more two-way by having the podcast and having the streams. But other than that, it's really akin to screaming into the void, which is not what I like. You get that? That's good. I'm glad you understand. I'm glad you guys aren't insulted. Like, because I'm not saying, like, I'm stuck with you guys. It's just that, like, I'm here. So instead of, like, watching YouTube, I'm working. And honestly, this part of YouTube doesn't feel like work. I mean, it's frustrating because I don't understand, like, what I'm doing. Like, look how long it took to freaking program a Pi Pico. So that part is frustrating, but that has nothing to do with YouTube. It's just frustrating because the instructions are bad or non-existent, or, like, Google sucks at finding instructions now too. All right, so take this little guy. So this guy is now perfectly soldered in 0.1 inch. So that's good. But you see those pads? You see how like little space. I'm gonna try, see that shiny, those pads? Yeah, not a lot of space in there. So you really have to go in and solder really small wires. So if you need all those pads, it's best not to use that guy and instead spend a couple extra dollars and get the Ultimate Pico, this guy. So this is like, this one's $3, this one's $3.50 Canadian. So it makes sense that when you've got a small area, you want to use that little guy. But if you've got more space, why not just use this guy? This guy's also flat bottomed. Nothing on the bottom. This one is dual sided. They don't mind doing dual sided boards because they know that you're going to put pin headers on it, most likely. Although, I don't know if you noticed, but these guys have castellated the pins. Yeah, it won't focus now. That's because I turned off autofocus, you dummy. The pins are castellated. The holes are castellated. So you can surface mount this. I just don't know how, because you've got a chip there. So I guess you would make a route cut around it to integrate it into a board. But the fact that you get the RP2040 in such a small form factor is incredible. Okay, so now we want to set this up where we can solder it in. So I'm going to pop it there. That looks about right. So we're going to put female headers all around there. So this will sit in properly. And then we'll put male headers coming down. So that's going to be complicated because this is not dual-sided. Let me think about this 1 second here. Do I have some of these that are dual-sided? Because if so, that's what I'm going to need to use. Let's see. Survey says, yes, dual-sided. Good. So I do have some. See, I love keeping stuff in stock because like if I had to stop now to do this project, that would be stupid. So I think this guy might be small enough. Whereas, yes, see, that's perfect right there. So I'll be able to slide that in, say on the edge here. I don't need these pads though, so really I can go this way. I don't like that it's not centered. It bothers me. But it can't be centered. All right, so maybe I'll go, seems to fit perfectly this way. So I'm gonna go this way. And if I want to shave this off, I can shave this off. Because I do want room to prototype on the side here. See, I might chop it, or maybe I'll give myself one more space, like that, and I'll chop it through these holes here. I think so. I think that's what I'll do. Okay, so we've got our adapter board. Put this back in the soldering bin. Ooh, my stomach is growling. I'm hungry, but it's 10:30. It's not that bad. All right, so pop this in here. I have to go get all my female headers now, which I absolutely despise, those female headers, because they're not the right size. They never are. And that should fit perfectly in a breadboard. You can't go in one because these pins won't line up. So you have to go out one. Oh, I just thought of something though. These pins are not going to be usable, so it does need to sit this way. Because if it sits this way, then I'll have this whole row here, which I can attach pins 13, 12. Actually, since this is 0, I can make this the whole length here. So that makes more sense to me to run it this way. And then I'll trim it off there if I have to. Maybe I'll put it this side. Then I'll have from 0 to 13 here. And then here it'll be smaller. So yeah, I think that's what I'll do. That's the plan. Now, to find my female headers, which is challenge mode. So I've got some male headers for later. Do I have some female headers hanging out in here? Some hot glue sticks. Female headers. Female headers. I don't see any. Some angled male headers. No female headers. Okay. Take a quick look. I have been buying female headers and putting them in a box somewhere. There's screws. These are not them. Small box though. But I don't know if I'll have one the right size. Let's see. Are these it? No, that's screws. This, oh here, female headers. Oh. Nope, that's not female headers, that's female headers. If you guys can see the disorganization. So I have up to 4. I have 2, 3, and 4. And I need here 1, 2, 3, 4, 5. Obviously I need 5 when I have up to 4. Oops, you guys didn't see that. I have 2, 3, and 4. I need 5s. Well, to hell with that. What's next? Down here. Okay, where are my female headers? Turn on these lights. Sorry guys, you won't see for a little bit, just because I'm off screen hunting in a big box of connectors, which I probably should organize at some point. Relays, NC4s. A big block of female headers, but that's for Raspberry Pis. Nope. Nope. So the problem is, I know I used my female. Oh, here's some. That was easy. Okay, good. All right, so the annoying part of this is that because this has to butt up right against it, these things only have one good edge. So if you see this, this edge here, that's the factory edge. And unfortunately, what you need to do is you need to do this whole row and then cut a brand new one at this factory edge and then a brand new one at this factory edge. You have no choice. This is why female headers are horrible and they're wasteful, simply because of that, that you can't fit them. You can custom cut them, but they never end up nice like the other ones. All right, so cut this one. Hopefully that's right. Because you see when you chop them, you always have that, see that sketchy edge? And if you cut it too tight, then you break through in the other hole. So let's see if this matches. It does. There we go. And you see now, if you have that crappy edge, it won't butt up if you put it this side. So you need to use a brand new end on that side. You also have to trim this down as much as you can, because then, you know, your other pin headers have to come here. So then you cut this one. So you see it like that. You cut this one. See, it doesn't fit. So you're missing one. You have to use the factory edge to butt it up against, like so. It's really annoying. Hang on. I'm about to make a mistake. No, I'm not. Okay, so cut here. That, and you just trim this back as much as you can. Sends pieces of plastic flying everywhere, but that's okay. Okay, and then now this piece, I don't know where it went flying. The female piece that we cut off both sides, see? That's an unrefined edge. That's an unrefined edge. Now you can't use this for here because there's a pin missing. So now you need to use a brand new one, and then you sit that like this, and then you can cut this one. It's not a great system. So really, if you have the budget for it, you really should order like in every single length, which kind of wasteful. All right, so I'll go right on the edge here. And we're gonna solder this. This is gonna be a little pain, bit of a pain to hold, but it is doable. So I'm gonna grab that, like that. Quickly bring in the solder. Quickly, I said. Quickly bring in the solder. Hold the whole micro up. And then that should hold. I'm going to go to the other corner. This corner. Hold that in there. Put some solder on. Hold that in there. Then let go. There we go. I just realized there's a problem now, though. How do I link these two? The pin will be in the way. Have to desolder this. This is not going to be an easy board to do, because you have to link these two holes somehow. Yeah, I didn't think this through. Because you can't link these and then drop the pins in. The pins would have to come through this side and then be double soldered. Okay, let's try it. I'm going to try it. Screw it. We're experimenting here, folks. This would be way easier in a custom PCB. The thing is, though, I can design a custom PCB. I'm not going to get it until late February because China is on holiday. So we're going to try to make do here. If not, we can build a flying lead contraption. Okay, so that solves that. Now we need all of these until like I, then plus 1, 2, 3, 4, 5. So I plus 5. So now I have these, right? And they go all the way to I. Then 1, 2, 3, 4, 5. We cut it here. That might be one extra. Okay, does it, oh, it's having issues sliding down. Because of what? Because of this female header here. That is a tight fit because of that female header. It's pushing everything outwards, so it doesn't fit. Okay, trying to push it out. We have to sand. We have to sand this female header. Look how much trouble this is. A custom PCB, I would have already done the design. It'd be already off to China. Crazy, huh? How much work some of these things end up being. So we need to sand that female header. We're going to order how much? 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 and 5. 9-pin female headers and 5-pin female headers. So yeah, now I'm here sanding this like a freaking lunatic. I have to be careful also not to damage the board. See, this one should fit squarely. Oops. Should fit squarely on this side. Let's make sure before we blame something. Yeah, that fits square. Because really, the pins should be this way. But you can't do it like that. Because how are you going to solder? Oh, you know what I can do? I think I will put it this way. Because then I will rip the black plastic off. That's what I'm going to do. I'm going to take the black plastic off. Solve my own problem. Still need to sand this a little bit though. that's what I'm going to do. I'm going to rip the black plastic off, and so I won't need to deal with that cumbersome task. So I grab this, take this, these go like so. And then just solder these in. Is that flat? That's pretty flat. Pretty flat. All right, should be able to solder all of these. Okay, here I can't see now because it's very tight. So let me just grab my soldering visor, which I put somewhere over here. Here it is. This guy here, if you're wondering. Ouch. Just freaking hit me in the nose. Okay, I can see a little bit clearer. Not a lot clearer, but a little bit. I feel like I'm a dentist. Still needs a little light though. I mean, there's a little LED on it, but it's not bright enough. There we go. All right, that should work. All right, now on the other side, I just need the exact amount. Can't see. Oh, you know what's funny is the micro came with the pins, so I could have just used those, but that's okay. It's all right. There's no problem. Here. So there, I have too many. Snip off the 2. There we go. Flip this around so we can both see, you and I. Lots of lurkers today. You guys are just hanging out, not saying anything, which is fine. Don't bother me much. I'm just calling it like I see it. You guys are quiet. Too quiet. What are you up to? I think you guys are plotting something. You trying to steal my LEDs? Is that what you guys are doing? I know you're trying to steal my LEDs. Yeah, that's pretty flat. Good. Did a good job. Pat myself on the back. Do you have to say, even if you guys are busy and you're not talking, you just have me on the second monitor or something? Appreciate you being here. makes the YouTube process a little bit less lonely. And then when I say something you don't agree with, you're all gonna come out of the woodworks and yell at me. Oh, I saw someone wrote some text. What did you say? Watching and playing a stupid farming game. Oh, which stupid farming game? I love stupid farming games. All right, now the key. We're going to try to lever this plastic up so we can access the backside. Like so. Like so. And we just try to get underneath there. Township. Okay, never heard of it. I play Stardew Valley. And JB is in bed. Make yourself some soup, JB. Always makes me feel better. So this is a very slow process here, but we're slowly lifting up this plastic. And I know I'm damaging the board a little bit, but I think this is the only way to do it. I'm pretty sure, you know, now that I think about it, I'm pretty sure oh my God, what's his name? I've been horrible with names lately. British bloke. Makes awesome YouTube videos. Oh my God. What is his name? Julian Eilert. Jeez. No, Big Clive's not British. He's Scottish. So I'm pretty sure Julian Eilert has done this before, lifting the plastic off these pins. I'm just not sure why he did it. He's always up to something, right, Mr. Eilert? Julian. He's always up to no good. Doing something he's not supposed to do. This is a lot more effort than I expected it to be. Cut between some of the pins. So I don't want the thickness of my cutters to end up splaying the pins, because then it's going to be a freaking nightmare to realign it. But I think the other issue is that some of these pins got quite heated and the plastic got soft and melted around the pins some more. Although I could probably hit it with the heat gun to make it a little bit more pliable. But I'm at the point now where I can probably lever in between. Welcome back, AB. Mr. Bryant himself. Adam, are you related to Kobe Bryant? Julian was one of the first. I used to watch for me. I used to watch AVE. Don't watch AVE anymore. And I won't really go into the specifics. It was I was saddened. Let's just put it that way. But I believe he went too far. I can tolerate quite a bit of stuff on YouTube without like cutting people out, but I had to cut AVE out. Sucks because he was a tradesperson, right? So there's solidarity there. Seems pretty knowledgeable, but on some things that you ought not just go in blindly and say, he went in blindly and said, and he's otherwise intelligent, so I don't know what led him to his beliefs. Just sad. I think you understand. I would shake, you know what, in person, I would shake his hand and I'd say thanks for all the great content that I consumed, but it's just, you know, when certain things you just can't separate the creator from. It's sad too, because I was like, I had him on my list when I started the podcast. He was on my list for the top couple people to interview that I wanted to interview. That list is dwindling. There's only a couple people left on that list. Adam Savage being one of them. Would love to talk to Adam Savage. I know the best way to talk to Adam Savage is to go to Open Sauce. There's a party when you're a creator and you go there. There's a party that Adam Savage attends. So that would be amazing. However, I'm just not in any, I don't have any capacity to fly to California, and not that I would for the next couple of years till things quiet down a little bit. All right, let's see if we can straighten these pins before we solder to them. Yeah, look, they're really splayed by my efforts. Oopsies. Let's see if I can stick them in here and straighten them a little bit. That is nowhere near straight. That's the bad part about removing the black plastic, is there's no more structure. They can kind of bend at will. But yeah, about non-controversial figures, well, Julian Eilert, he's the bomb. And he was there for so long, too. He's just like so early into electronics. Published in magazines and stuff. What a friggin' guy. Okay, it looks like I will need to trim the board edge like I assumed I would. There we go. Because see, if you set it like that, or you have one row of pins here, you have 0 on this side. So I'll have to cut through these holes, sadly. I guess I really should have put them on the inside. Whatever. I will have a custom PCB designed. Oh, shit. Undid the power rail there. I'll have a custom PCB designed for this pretty quickly. Just don't know when I'm gonna receive it. Okay, so that's pretty straight. Now we're just gonna solder bridges across all these all the way down. And then these guys we have to do little jumper wires, or we can just go, you know, bridge, 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 all that. I don't know if I want to do it with solder or with wires yet. Wires are a little bit less trouble, but then you still got to make them. All right, here goes. Can you guys see well? Like, do I need to mess with the focus again? Are we okay? What about if I full screen this so I can see a little bit better? Bring this down so I can see a little bit better. Properties, configure video. That popped up on the other screen, obviously. And then focus. Better or worse? What's the closest focus it goes? It's too close. I end up nearly in the same spot. It's not terrible. Good. Not great, not terrible. How's it going, Kevin? Did I see you just subscribe to me like yesterday or this morning? I feel like I just saw, I got a notification. And your name sort of seems familiar. Gotta put my my visor on. This guy. Yes, this morning. There we go. Welcome. Welcome to the stream, where we have spent probably the last hour, maybe more, trying to program this RP2040 board, and now making an adapter so I can make a so I can do some breadboard prototyping. And much worse than that, this was supposed to be a very simple project. That's bridged. I don't know if I'm going to be able to bridge all the contacts, but here we go. Oh my God. And I'm working it around the webcam too. Oh no, it bent the pins. Shit. Without the plastic structure, the pins just went wonky. There, you can see it's like buck teeth. Okay. So we're scrapping that. Damn. That is horrible. That was all that work for nothing. End up in the scrap pile. Excuse me. Still have my freaking cough. Okay. Next thing, we're doing a wire interconnect until my custom PCB comes in. I mean, it just, it is what it is. Excuse me. I'm just dying a little. Okay. It is what it is. I mean, this is what I'm talking about. Like, making videos takes a lot of effort, because even though we spent all that time trying to make an adapter, we didn't even manage to complete it. So There we go, and we'd make more adapters. Okay. How many pins? 5, 6. So I need 9. I need 9 pins. So that doesn't work. Do you have an IC socket you can put over the pins to hold them in place? Damn, that is a good idea. I don't have one with enough pins, I don't think. But anyways, and then access is getting very tough. I think I'm just going to do a pin-to-pin interconnect. I think that's the most logical. But the problem is when you go pin-to-pin, it's difficult because these pin headers are really only good for one side. That's funny, hackers. Do you want me to delete the comment? Here. Remove. Oh, it doesn't delete the name. Oopsies. Can I restore? No. Well, sorry, I deleted it, but it is what it is. Okay, so I think what I'm going to do, excuse me, I'm like freaking dying here. So we're just going to use pin to pin. I have a box called breadboarding, but I don't know where the heck it is. Switches, power regulators. What the heck? What the heckin' dog? Soldering. That's there. I have this organization. Oh my god, it's right next to me. You nincompoop. I took it out specifically to do stuff, and then I forgot that I had it out. Oh boy. I need some rest. Okay, that's 4 pins. So I'm looking for these pins that are all together to keep it neat. So I need female. Oh, I got you, hackers. I need female to male if we want a breadboard. I think I just need to order more. Look at all these female to female. Tons of them. Female to male, that's 4 pins. This 3. Where are all my female to male? Do I really use female to male that much? I mean, I guess I do. But yeah, I guess this is not going to be easy to develop for without a custom PCB. I wonder if, okay, does Waveshare, do you think they have a footprint for the RP2040-0? That's the next question. Okay. What's going on here? Let's see. Let me get here. RP. It'd be funny if AI can generate them. That'd be pretty neat. RP 2040 0 footprint. I know I can make it. Does it have a PCB footprint? So that's 0.1 inch, that's fine. They have all these dimensions. I wish they had a KiCad footprint though. Okay, you know the other thing you can do is go to PCBWay.com and the shared projects, and then search RP2040. Actually, I should probably search for the 0 specifically. Okay, so this tells me, aha, that's good. So since there's people that have made footprints, then I can use them. All right, Gerald, get me some tea while you're at it, please. Thank you. So they, oh, they're using the castellated edges. Okay. Dang you. Uh-oh. Why does it say JLC all over here? He's Canadian. Please tell me this wasn't stolen. I sure hope he posted this. Did someone just upload this? Okay, I feel like it's just a link to a GitHub. Okay, so I can't use his footprint, so because he just uses the castellated edges, which is neat. This one too seems to use the castellated edges, and so does this one. So essentially, I need to make my own footprint, which is fine. Send you guys to the naughty chair. I installed a better KiCad. I thought, whatever. I updated to 8 point something. I'm going to bring you back in a second. I'm just setting up my stuff here. Pi 2040 0 adapter. Footprint time, yeah, it is. I haven't made a footprint in a little bit, so no guarantees. Also, I do realize that the scale is not good for you guys because my screen is in 1440p. So sorry about that. If I make this bigger, the stuff doesn't get bigger. But anyways, a symbol editor, we're going to go into here. Do I have my custom? I don't have my custom anything. Ugh. Every time I do this, I have to re-enter my libraries. I hate that. RP 2040. Let's see if there's anything. Okay. So then there's no 0 for sure. Okay. So preferences, manage footprint libraries. That's the most important. Send you off for a second. Ugh. Oh wait. No, my custom libraries are there. Well, I'll be. Okay, we're good. We're good. So let's make a new symbol. New symbol. No symbol library detected. Okay, I have a custom. Should be a custom. CPU. What is in device? No. Oh my god, I'm horrible at this. Preferences, symbol libraries. Excuse me. Just dying here. Don't mind me. So I have custom libs, these things. Oh, I put one. Okay. So I don't have like a custom. I made my own, put it in its own folder. That doesn't make sense. Okay, so add empty row. How do you do this? Empty row, custom parts. Oh, there's a custom symbol. Open, open. How do you, what's going on? How come I can't delete this? Trash, there. This, custom symbols, open. Okay, whatever. It's just, can here, new symbol thing. Oh my god. Why is this so annoying? Okay, file. New library. Global. Okay. And then I'll just take in custom symbols. And then custom symbols. I think you need custom symbols. All right, good. New. Symbol name. RP 2040 0. U. Units per package 1. Sure. Sure. Okay. Good. We're on our way. All right, I don't know how many pins I need. Okay, there's okay, yeah, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there's 23 available plus all of these. 6, 7, 8, 9, 10. 23 plus 10. So it's going to be a big symbol. I don't know how many, whatever. We'll reshape it after. Let's do the pins first. Okay, pin name. Let's grab this, put it over here. Pin name, 5 volts. The numbered is not numbered. 29. 23 plus 10. Sorry, I'm too dumb right now. 23 plus 10, and then we have 4 minus 4. So we have 29 pins. Do we have anything GPIO above 29? 29. No. So 5 volts, I'm going to call that one 33. 33, and that is a power input line. I mean, I'll figure out these positions after. So 5 volts. Pin. FreeCAD skill is lacking. Yeah, mine too. I has their dumbs. Yes, I do have their dumbs. That's me. 33. We got 32. Pin. Oh, wait, the name. Ground. Ground. 32. What do you call ground? Is it just an input? Passive? What? I don't think that one was supposed to be a power input. Welcome back. Any footprint aficionados know what I'm supposed to put as when it's a power pin or a ground pin? Put edit input. I'll just start by frickin' doing the damn thing. I want cheeseburgers. 31. Ah, goddamn it, did it again. 3v3. 31. Okay. And then these, so all of these I'll put on one side. And then these guys I'll put all on the other side. All right, and then pin number, so this I'll do left side. I should really do that backwards. Yeah. No, whatever. Left side, pin number 30, ground, pad. I'm going to call it pad, and it'll be on the other side. Did I mess that up? Oh my God. $30. I was like, why does it look weird? Okay, next one. 29. That'll be GP 29. And then that'll be right. And then next one, GP28. GP28, and that is number 28. And then GP27. That is going to be 27. See, this is an AI task. This is something AI should be able to do. GP26, pin pin number 26. Because like there's no skill. I'm not skillfully entering the numbers. I'm just copying whatever it says. Excuse me. 15. So I'm going to put them down in order because I think that's better. Yeah, anyways. Name GP15, 15. If anyone doesn't like it, well then they can modify it themselves. Pin name 14, GP14, yeah. GP14, pin number 14. Then GP13, pin number 13. And GP12, pin number 12. GP11, pin number 11. GP10, pin number 10. GP9, pin number 9. GP8, pin number 8. GP7, pin number 7. GP6, pin number 6. If I'm getting annoying saying this out loud, let me know. GP5, pin 5. GP4, pin 4. GP3, pin 3. GP2, pin 2. GP1, pin 1. Oh no, do I have one too many pins? Because I counted GP0 as 1. I'll modify the other ones after. GP0, pin number 0. Okay, that's one whole side, and then the other one is ground. GP25, pin number 20. I guess it's 25. And then this is left. Oops, I forgot to write that it was a pad. So edit this. GP25, pad. I'm going to put this in caps. GP24, pad, pin number 24. GP23, pad, pin number 23. I hope people will come and use this this footprint that I'm making because this is long. GP22, pad 22, GP21, pad 21, GP20, pad 20, GP19, pad 19, GP18, pad 18, GP17, pad 17. Okay, so now my question is there a 29? 28, 29, 30, 31, 32, 33. Did I miscount? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's no 16. There. I did miss one. 16. So that one's not exposed. Okay. So GP16, LED built in, although it's not LED, it's not a built-in. Pin number 16, and it is not an input, it is unconnected. You can't use it. So that is our drawing. So let's put a square around it now. Like that. And then we'll grab this U, we'll move that. Grab all of this, move that. So if I have, I want it to be equidistant. So how many do we have here? 1, 2, 3, 4, 5, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So we want 11 on each side, so this is this. That works. Our U, we'll move it to here. And then here we'll add some text. RP 20, oops, RP 2040 0 wave share. Okay, we'll put this right there. There we go. That is our schematic pad thing. How does it look? You guys like it? Can you guys see it? Can I zoom for you? There we go. A little bit bigger, so now you can see it. Morning, Mr. Ireland. Ireland. So that's done. So very likely I'm going to publish this on my GitHub when I get the my footprint done. So I think it should be pretty clear that what these things do, and that these are the pads on the back, and the GP16 is not even connected. So you can't reach it from anywhere. So that's good. All right, so that's done. So that's saved as the RP2040. So we're going to close that, and then we're going to make a footprint. Footprint is going to be easy because it's 0.1 inch headers. So as long as we set our 0.1 inch headers up in the proper spots, it'll fit. All right, so set the grid to 0.1 inch, right? That's 0.1 inch. 2.54 millimeters, yeah. Good. All right, so now we need make a custom. So I use uncategorized parts usually for my footprints. There's no custom CU. Oh, custom symbols. Oh, symbols, okay. So not there. So uncategorized parts, and then new footprint. RP2040 wave share. Footprint type through hole. Okay. There we go. Okay. So let's now set our pads, but there is a wizard, I think. Tools. I think there's a wizard to put pads down. Properties. Tools. Doesn't really say. Whatever, that's fine. So let's get it started. Let me just grab my failed PCB from this morning, because that will tell me the distances. Okay. So we need the pads spaced 1, 2, 3, 4, 5, 6, 7. There's 7 holes apart. So if you just place pad, let's say anywhere, there. 1, 2, 3, 4, 5, 6, 7. There we go. So that's there. But we don't want to do that. We want to put them here. 2, 3, 4, 5, 6, 7. How long are they? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, and then 5, and then 5, 6, 7, 8. Is that correct? 1, 2, 3, 4, 5. Then, oh, there's only 4 here. Whoopsies. So there we go. It's that simple. This is how you place them. So I only have 29. Does that make sense? 2, 3, 4, 5, 6, 7, 8, 9. 9, and then 5, and then 9. That's it. That's all the pins. So if I grab them, that, and I move them, and I think now what you do, because you have to link these to something, right? You have to say what the number is. I'm trying to, like, do you make it from, oh, there's the wizard. Cancel. Yeah. Actually, file. Footprint properties. How do you add it? Footprint. There we go. RP 2040 wave share. This, okay. Okay, so you got the footprint added now. I don't know what the show is. Okay, and now you have to number the pins the same, if I remember correctly. The pin numbers here have to line up with the numbers there. So if we do this symbol editor, custom symbols there, we just have to number these to line up with those. So since I did it in order, it should be easy. So edit, this is pad number 33. And I'm actually going to change this to oval for ease of soldering. Two. No, the other direction. Change this to 2. Hole shape circular, that should be fine. Okay. Edit 32. Oval 2. Okay. Edit 31. Oval 2. Okay. Edit 29. Oval 2. I should have changed the default, but that's fine. Edit 28. Make sure we're still on track here. Oval 2. Okay. And when we get down to here, just to make sure we're still on track, when we get down to here, 15 and 14 should be the last 2 pins in that row. So 27, oval 2, then edit 26, oval 2. Okay. No, something's wrong. I miscounted. 1, 2, 3, 4, 5, 6, 7, 8. I did miscount. So all this needs to move down 1. Like this. I have to add a pad here and add a pad here. Oh shit, my wife is making food. Do you like their wiki? I didn't find it that great. I was having lots of trouble programming this RP0. 15. 15 oval 2. Okay. Edit. 14 oval 2. Okay. So my wife is making food, so I'm inclined to go help her. Let me send you to the dog pound for a second. I just want to send want me to end and help. Sorry about caps. There we go. And back to screen. So I'm asking her if she wants help. She's going to say no, but now we have to try to determine her actual intentions. Okay, 13, oval 2, okay, edit, 12, oval 2, okay, edit, 11, oval 2, okay, edit. I have to say though, I don't praise me for buying a Waveshare thing. I ended up buying on AliExpress. I'm not even sure if it's Waveshare for real. Oval 2, okay. Oh, actually these guys, I want oval in the other direction. I wish there was a flip button here. 1.524. I'm gonna copy this. Oh, actually, maybe I just put 90. 90 works. Just do 90 on all these. Edit. 90. Edit. There we go. See, you don't have to do anything different. 90. 10, edit, 90 degrees, edit. So after 10 is 9, oval 2, 90, okay. And then after 9, it's 8, 8. So the only thing is, I'll have to tell the system that these aren't connected somehow. Pad 8, oval 2, because or else it's going to freak out on the DRC, isn't it? 7, oval 2, okay, edit, oval 2, oh, what was the pad after 7, 6, I go all the way down to 0, okay, 6, wife answered, what did she say? She said no. So, okay, so she said no, but what does she mean? That's the question. Because I know she doesn't need help, but isn't it nicer to help? 4, oval 2, edit, oval 2. Where are we at? 3. Okay, edit 2 oval 2 1 oval 1 up 2 and then there should be 0. Need is a strong word. Want help. Yeah. Yeah. Wait, what did I say? I asked her if she wanted. She said no. So I guess it's a no. We will respect our significant other's wishes. That's how we roll. Okay, so move that up. That should be a bit more even. That looks good. Move the reference up here. Shall move the reference more like here, because we're going to put the USB here. I'm going to put a rectangle. I'm going to change the grid. Put a rectangle there, and then we're going to put a rectangle here to indicate the USB. Should be bigger. It's pretty big on the actual thing. There we go. Hey, Franco. I missed you this morning. Where were you? So I think this is it. That is our footprint. That should work just fine, and it'll line up with the pins I have here. So that's good. I don't know how to tell it, because they're footprint, yeah, footprint properties. I don't know how to tell it how that there's going to be missing some pads. I'm not building a 3D model for that. May too difficult. Well, welcome. Welcome to the stream. Just towards the end, probably in 15 minutes. It's going to be the end. Excuse me. Still have this stupid cough. I've been coughing for over a month. So anything else we should add to this? I think that's good. And then, you know, the other pads are going to be here for my adapter board. Could go on the inside, but the only thing is you can't get the other pads. Can't get the, like, you can't get the other pads that are here. On my adapter board, I might make it where you have to solder wires to pads like underneath here, surface mount pads, and then they will lead to another set of pins over there. So I'm probably gonna make 2 versions, essentially. But yeah, that's the gist. I mean, so now if people want to make these footprints, now the footprint is there. So if people want to make their own projects with them, including me, so that's done. Cool. Well, I don't think I need to do much else. This is finished. I just have to see if, I guess, it passes DRC. Is there a way to set it to say that there's not going to be pins? Pins 17 to 25 are only available via pads on the back. Pin 16 only connected to NeoPixel. There we go. This is KiCad 8. This is KiCad has like modules, so essentially when you open KiCad you get this, and then your schematic editor looks like, or your footprint editor looks like this. Your your symbol editor looks like this, so I made this symbol today. Your footprint editor looks like this, I made this footprint today. And then when you want to make your schematic, you hit the schematic editor. That's what it looks like. And then when you want to make your PCB, you hit your PCB editor. That's what that looks like. KiCad is incredible. It takes a little bit to get used to it, just like any other piece of software. But honestly, I feel literally zero need to go to a paid solution. This is it's an incredible piece of software, and it's only been getting better. It's incredible. I'm beyond belief on how good it is for a free piece of software. The drawing sheet editor, calculator tools for calculating resistance, current, they've got everything. Oh boy, I don't like that though. Whatever does that slow motion zigzag. But the size of your via, all this stuff, it's all in here. It's been on your list. It's fantastic. That's all I know. It's a great piece of software. And you can check out viewer Gerbers. You can convert. I've converted bitmap images to footprints. It's incredible. I think pretty much everyone who's here, Franco, have subscribed. So yeah, I'm gonna, didn't mean to close all that. Well, I'll just go over here because I'm almost done the stream today. So essentially, I'm going to create a PCB probably today during Vero's stream. Vero is streaming later on twitch.tv/VeroWhack. During her stream, I'm probably going to make a PCB for this, so that'll be ready to go. I want to get 3 or 4 PCBs done so I can send them off to get manufactured after the Chinese New Year break, which I'm not sure when it is. Because some of you have noticed, not all the podcasts are sponsored anymore. So I don't want to complain because they are still supporting me, but they're really more interested in me making projects. So yeah, that's a little bit of a blow, but it's not a big blow. It's not the end of the world. I'll figure it out. But yeah, essentially, that is that. So we were trying to make something simple right here. We didn't even get to the prototyping stage because this doesn't fit. Mind you, I could have just not soldered these and then just did it with the other ones. But anyways, that brings us to another video, which is great. So now we'll have so that was number 1 over here. But if I take my pen, we have essentially number 0 adapter for RP 2040 0. So in the chain where we had 4 videos, Now we have 5. So we got 1, 2, 3, 4, and 5. So for those of you that came in late, so the plan is one video to adapt this to breadboard for prototyping. So that is good. Then we're going to make a servo tester, which we're going to also use this for. So servo tester. So yeah, we're going to make a project for that. So that's 2 PCBWay videos. Then we're going to do a servo force tester. So we're going to make a cool little device to test the force of these servos. So that's number 2. Then we're going to make a video. So that's 3 devices. 1, 2, 3 PCBWay videos. So I'll put a sponsor for that, sponsor for that, sponsor for that. And then we're going to test the servos I have in stock. So that's why this one was here. So that was my original thing, is I wanted to test the veracity of these claims. So that's not sponsored. And then multi-servo controller, that could be a sponsored video as well. So essentially, if I don't have any projects ideas, I've got essentially 4, I think PCBWay wants max 2 a month. So I essentially got 2 months of PCBWay videos on this piece of paper, and I'm going to space them out more. So we're going to do more projects, obviously. But yeah, I want to get to doing projects. What is the small PCB module? This guy? This is a RP2040-0. So it has an RP2040 chip on the back there. See that? And it's got storage on board. And so it's an RP2040 in a small form factor instead of the RP2040 typical size, which is this. So I'll be able to have more control over my projects when I use this compared to this, because this is much larger footprint. Because don't forget, PCBs have to be a maximum of 10 by 10 centimeters. So when you go 10 by 10, this grid is in inches, so it's not very good. Excuse me. 10 by 10. Do I have something that's 10 by 10? This is close to 10 by 10. So when you have a 10 by 10, okay, and you're trying to fit a lot of components on it, that takes up a lot more space than that. What does it do? This is just a breakout board, a microcontroller breakout board. So it's like an Arduino. It's essentially an RP2040 chip, and this is just the actual. This is just an RP2040 in a different form, and it's got memory, whereas these don't typically have memory. So my first board is going to be an adapter for this to go into a breadboard, because you can't, as you can see, you can't breadboard this. And also, I don't know if you noticed, but there's pads along the top there. Twitch channel, twitch.tv/Verowak, VEROWAK. So you see the pads up here, just underneath the yellow, like right up here, just over my thumb. See, they're shiny. So to keep this board compact, because it has the same amount of connections as this board, they put some of the pads over there. So you can reach them, but you have to solder little tiny wires to it. So my adapter board will probably have 2 revisions. One that you can solder to those and then have the breakout pins for it, and one that you cannot. Yeah, it's like an AT Tiny, but except it uses the full fat RP2040 chip. It uses literally, so this chip is incredibly powerful. In fact, I'm looking at this. This has a different chip on it. The size difference has the more pins. That is the RP2 B2. I don't know what that means. This one has the RP2 B2 as well. Is this not a 2040? Hold on a sec. I was supposed to go. Different revision. Maybe. Oh, hang on. All right, my wife is saying food is going to be ready, so we have to do this quick. Screen. RP 2040 versus RP2 B2. What's the difference? Okay, they're RP 2040s. Okay. B0 is the original production version. There was subsequent minor respin, and that is the B1. Don't know what the other numbers are. B0. So B2 is a different respin. Okay, so it's still a 2040. All right, we're good. All right, so I'll be in the chat in Vero's stream, I think at 2 o'clock in 2 hours. So hopefully you see you guys there. I'll be working on some PCBs while she streams. So thank you everyone for being here. I appreciate you folks. Sorry we wasted our time building an adapter board that didn't do crap, that didn't work. But I'll catch you guys in the next one. Have a good one, folks.